Well, it's time to put two power modules together and try some load sharing. The drain of the power MOSFETs is not electrically isolated from the heatsink. I just can't afford the increase in thermal resistance that would bring. So I'm going to mount the heatsinks together with plastic, keeping them electrically isolated. Even though the MOSFET drains should have the same voltage on them, if I keep the positive power wires the same exact length. I made a fan shroud that will move the fans back a bit from the heatsink fins. In testing the heatsinks, I had the fan right up against the fins, so some of them really didn't have air flowing across them. Hopefully this will improve the airflow over the entire heatsink. I'm just holding the fans and shroud in place with some double-sided tape. Then everything gets wired in parallel. The fans get wired in parallel. The power module wires all get wired in parallel. I know the multiple grounds here are going to cause a problem, but I'm just going to do it and see how it works out. I did make some modifications to the control circuit. It originally looked something like this. I knew this current sense section was going to be a problem. Using the ground here for the sense resistor is quick and easy, but a bad idea. So I changed it to this. The main reason being that the negative leads from the MOSFET power modules will connect to this terminal, which through a very small trace on the power module will connect to this J5 terminal here, which we'll call ground for now. So any unbalance in the negative power leads between the power modules will cause a load sharing problem. The complication this creates is now the negative power terminal and the negative load module terminal will be at a negative voltage reference to that ground. So to deal with that, I just added a negative 3 volt supply for the op amps. I also made a heavier sense resistor. The 0.1mm nickel was just getting way too hot at 15 amps, so I moved it to 0.21mm. After hooking everything up, time to get to testing. Here, when I first started testing, I was getting quite a bit of difference in current between the two power modules, about half an amp, with 15 amps of total load. I thought I had made the power leads the same length, but after a bit of investigation, turns out one of the power modules' negative power lead was about 2 inches longer than the other one, so I just eye-sighted them to about the same length and then back to testing. Now at 15 amps, it's much better. There is only a 100 milliamp difference between the two power modules. That, I think, is excellent. It takes a bit of time after adjusting current levels to get a stable reading, as my current sense resistor is just some nickel strip with a horrendous temperature coefficient, something like 6,000 parts per million. At the higher currents, thus higher nickel temperatures, it's a little sensitive. Moving my hand around the nickel strip does affect the current levels a bit, but not instantly, so I'm sure it's my hand affecting the air movement around the sense resistor, altering its temperature. At just a bit over 20 amps, it's less than a 100 milliamp difference. I think it will only get better when I remove the power leads from the equation. Just going to turn it up a bit and get to about 21.5 amps. That puts me a little over 300 watts total, which is what I wanted out of this test, a pretty well balanced 300 watt load. I calculated I'm right at about 152 watts for one MOSFET and 153 for the other. And if my thermal measurements and calculations are correct, junction temperature should still be 15 to 20 degrees centigrade below the limit. So from this test, I've learned a couple of things. I'm very pleased with the OPA 189 op amps. It's a little expensive, but not outrageous. I won't have to do any offset adjustments to it, which is worth a couple of bucks right there. For the main current sensing, I've got to get a proper high-power current shunt, something with a half-decent temperature coefficient, and a current sense circuit to use a very, very low resistance. And it's time to order one of the big 240 amp MOSFETs and give it a try. Thank you for watching.